This is important because we can use it to get some initial insights. Remember, we want to know what is the temperature gradient with respect to x and y at a particular surface here, surface B. So the first step to think about narrowing this down is to notice that the x component of heat flow at surface A, the component that's going left to right, and the y component of heat flow at surface B, the component that's going vertically, is going to be 0. Those components would never pass through the surface. Therefore, by Fourier's law, we know that the x component of heat flow is related to thermal conductivity times the temperature gradient with respect to x at surface A. Since we say there's no heat flow going through the surface, the x component of heat flow through the surface is 0. Therefore, the temperature gradient in the x direction has to be 0. If there's 0 heat flow, then there has to be 0 driving force for heat flow. K is a constant, that doesn't change. So already from this observation, we can rule out a temperature gradient in the x direction at surface A. Similarly, at surface B, since we know that the only direction for heat flow is in the x direction, the y component of the heat flow is 0. Therefore, the temperature gradient in the y direction is 0. There can be no driving force for heat flow because there's no component of heat flow in the y direction that passes through this surface. So this gives us one of the results that we're asked for. The temperature gradient with respect to y at surface B is 0 because there's no component. Any heat flow in the y direction would not pass through that surface.